Hi, I'm Alex. I'm a postdoc here at TU Darmstadt, and I'm the research head of the Generative Design Lab, which is the research unit that takes care of all these activities in 3D printing and additive manufacturing. And I'm here at our window shelf where we gather all these little specimen bits and pieces we use or we create in our research. And there's a lot of different materials, and I can just show you, for example, we do some research in printed ceramics, which is basically fired clay. We also are active in metal 3D printing, mostly through wire arc additive manufacturing, as we see, for example, here with this nice reinforcement cage that was welded as a prefabricated reinforcement cage for special purposes. We also do it a bit bigger. You can see this quite heavy knot that's hosting 5 different connectors where you can attach like facade profiles, and you can make fancy facades by just attaching a normal facade profile here and being not that rectangular as we usually are in facades. We also have some more exotic materials, for example, cellulose 3D printing. So what we basically do here is printing paper into shape. And also we have some glass 3D printing activities, which is still a bit tiny. That's why I have to search the pieces. We can see, for example, here, this is sprayed glass on a glass plate. It's still not transparent, but we're still working on it to get it working. This one looks a bit better. You can see this one is transparent, so this is 3D printed on a normal glass plate. What else do we do? We do thin sheet welding, which is a bent thin sheet of metal, and we weld with the robot on the backside in trajectory lines, and therefore we can use a much thinner sheet. We can save material, save the environment, but just applying stiffness in the areas where they are really needed to be. Or for example, what I like quite a lot is also this one, which is actually a bit rusty, but this is a facade connector for a non-planar facade. And you can see we have a back plate which is planar, but all these connectors are in the very point they are needed to be, and therefore we use 3D printing to create fancy facades. We've seen it with a lot of colleagues who are active in concrete 3D printing that can just build some concrete printed houses also in Germany, and they are quite far advanced. Other technologies, like for example my own research in ceramic 3D printing, is on the threshold to be implemented in the market as a product. But others, for example clay 3D printing or the paper 3D printing, are really in low TRL stages. It always depends on the material, and also in Germany especially it depends on the approval of the authorities, which is quite hard to get in Germany. Other countries are way easier to build your 3D printed houses. So this is our lab facilities where we do all the 3D printing, and Danielle here is printing some clay which will later be dried and fired, and therefore this is ceramic 3D printing, and it's a good way to showcase, to show you how we do it, because we come up with a weird geometry and we want to somehow create that, and for this we first split that into horizontal layers that are then created line by line. You see the nozzle going around creating one line after another, and the lines form layers, and the layers form later a geometry as soon as this process is finished. You see how slow it is? That's one of the shortcomings of the additive manufacturing. We take a lot of time to create our geometries by just layering 1 millimeter layers atop of each other. But basically this applies for most of the processes. Always depends a bit on the material. Here we have a paste. Sometimes it's thermoplastics, and sometimes it's also welding. This is just a 3-axis machine having 3 degrees of freedom, which is a bit more simple in terms of production. But sometimes we just need more degrees of freedom. We need to tilt the extruding head and so on. And for this, we have this beauty here, a big robot arm, which is currently equipped with a plastic extruder. So we have some plastic pellets in here that are molten by this one and then deployed by this nozzle. And if you look over here, you can see something I just showed you before. This is again a thin shield, but in this case it's not reinforced by welding on top of it, but by deploying plastics and by that reinforcing it. Again, these trajectory lines, but you see it's possible to also do this with other materials than steel on steel. And of course we can do some big 3D prints with that one, bigger than what you're used to from your little home 3D printers maybe, used for architectural modeling. And as this is just a motion providing machine, so to say, we can basically mount any tool on this. So we could, for example, just mount a chainsaw on it and carve something out of something bigger, which would be then subtractive manufacturing. But you can imagine we can do a lot of things with this beautiful big machine. And back here, closed right now, but you can see up there this arm pointing up. It's carrying a welding torch, which is used for this steel additive manufacturing, wire arc additive manufacturing. So you can see a lot more of that thin sheets here. You can see again the thin sheets that are reinforced over there, and down here some little tiny objects, some studies in parameters, some basic geometries, but all made from steel. Yeah, so this is basically what we are doing here in Darmstadt at the Generative Design Lab. And yeah, I'm always happy if somebody has questions. You can just write me an email, Google me. You'll find me on the university side. And yeah, thanks for watching.